Okay, so picture this. I'm at the grocery store, right? Just doing my usual thing. And I pick up some lotus root, pretty standard. But then I see this label, clear as day, free of citric acid.
Oh, interesting.
Yeah. And my first thought was like, wait, why? Why is that even a thing to call out?
Right. Is it usually in there?
Exactly. Is it normally added? Should I be worried if it is? It just kicked off this whole chain of thought.
I can see why.
And honestly, that little label sent us down a surprisingly deep dive into citric acid itself.
It's actually a perfect starting point because, citric acid is one of those ingredients you probably see, or rather consume, dozens of times a day, maybe without even thinking about it.
For sure.
So today we're going to get into its uses, which are incredibly varied, and its origins, which are, well, let's just say surprising.
Definitely surprising.
And why knowing a bit more about it might actually matter more than you'd think, especially, regarding what we eat.
Yeah, we found some real aha moments tucked away in the story of this, super common food additive. It's quite the hidden tale. Okay, so let's circle back to that lotus root, the initial question. Why would citric acid be in there to begin with?
Right, so our sources point to two main things, really classic food science applications.
Okay.
Preservation is one. It basically makes the environment more acidic, and that acidity makes it harder for bacteria to grow. So, it extends the shelf life, sometimes quite significantly.
Right, okay. That makes sense. And the second reason?
That's about appearance. Color protection.
Ah.
Yeah, if you've ever cut up an apple or maybe even peeled a lotus root yourself, you know how fast it can start to brown, right?
Oh, yeah. Instantly sometimes.
Exactly. That's oxidation. Citric acid is really good at slowing that down. It inhibits that chemical reaction.
So it keeps it looking fresh and, white and appealing on the shelf for longer.
Precisely. But look, it's not just lotus root. Its use is massive. Citric acid is one of the biggest biotech products globally. We're talking over 1 million tons produced each year sometimes.
Wow, 1 million tons.
Yeah, you find it adding tartness to sodas, candies, stabilizing things like cheese or other dairy products. It's even used in making pharmaceuticals, cleaners, cosmetics.
Yeah.
It's pretty ubiquitous.
Okay, so it's clearly super useful, almost. Too useful, maybe. Makes you wonder, is there a catch? Or, how is that much of it actually made? Because we tend to think, citric acid, lemons, limes, right, just squeezed out of fruit. But given those quantities, is that really how it works?
That is the critical question, isn't it?
Yeah.
You're right. Historically, yes, it was isolated directly from citrus fruits. Italy was a big producer back in the day.
Okay.
But imagine the sheer amount of lemons needed for 1 million tons.
Yeah.
It was laborious, expensive.
Yeah, I can't even picture that.
But then things changed big time. Around the early 20th century, 1917 sticks in my mind, an American food chemist figured out a much, much more efficient way, an industrial method.
Okay, here we go. What was that method? Because I feel like this is the part where things get interesting, the aha moment.
This is absolutely it. The vast, vast majority of citric acid used today, the stuff in your soda, your processed foods, it doesn't come from a lemon grove.
No.
No. It's made using biotechnology, specifically through the fermentation of sugars, like molasses or corn-based sugar, by a particular type of fungus.
A fungus?
Yes, one you might know by a rather less appetizing name, Aspergillus niger.
Aspergillus. Wait, isn't that...
It's commonly known as black mold.
Black mold? Seriously?
Black.
Hold on. You're saying this super common food additive, the one we think of as just, citrusy, is made using black mold?
That's the standard industrial process, yes.
Wow, okay. That is quite the revelation. I mean, hearing black mold and food ingredient together sounds a bit, alarming.
It does catch you off guard, absolutely.
But is it actually, harmful in the final product, or is the mold just used in the process? What's the deal there?
It's a good question. So, essentially, the process involves feeding this Aspergillus niger a sugary substance. As the mold metabolizes the sugar, it naturally produces and excretes citric acid as a byproduct.
Okay.
It's a very efficient biological factory, turning simple sugars into this chemical. Now, regarding harm, the industry is, of course, careful to filter and purify the citric acid. The final chemical product is supposed to be identical to the citric acid found naturally in lemons.
Supposed to be identical.
Yeah.
Okay, but...
For some individuals, this synthetically produced version might cause issues. That's what some of the research and anecdotal reports suggest.
Okay. So even if the molecule itself is the same, how it's made or maybe trace elements from the process could be a factor.
That seems to be the crux of the potential issue. Think about it. Natural citric acid in a lemon comes with vitamin C, fiber, other plant compounds.
Right.
It's part of a whole food matrix. The industrially produced kind is isolated, purified, and often consumed in much higher concentrations in processed foods and drinks than you typically get from just eating fruit.
I see.
So for people who are sensitive, our sources indicate a few potential problems. One theory is that there might be tiny residual impurities left over from the mold or the fermentation process itself, even after purification.
Impurities from the mold.
Potentially, yes. Or it could simply be that the high dose of isolated citric acid itself triggers a reaction in susceptible people.
And what kind of reactions are we talking about?
The reports range from things like inflammatory responses, maybe joint pain or swelling for some, allergic-type reactions like respiratory issues or skin rashes, and sometimes gastrointestinal discomfort like stomach upset.
Wow. Okay, so it's not necessarily a universal problem, but for a subset of people, this common ingredient could potentially be a trigger.
That appears to be the concern, yes. And it highlights why that free of citric acid label on your lotus root might actually be there catering to consumers who are specifically looking to avoid the industrially produced version due to sensitivities.
So, okay, let's bring this all together. That one little label on a package of lotus root really did open up a whole can of worms, didn't it?
It really did. A fascinating journey from the produce aisle to industrial biotech.
We started simple. Citric acid is used for preservation stops bacteria and for keeping things like lotus root looking nice and white by slowing down browning, the oxidation.
Check. Standard food science stuff.
But then the big reveal. Most of it isn't from lemons anymore. It's made industrially using fermentation with Aspergillus niger, black mold.
The kicker, exactly.
Right.
And that's the piece that connects directly to potential health concerns for some people.
Right. Those potential inflammatory reactions, allergies, gut issues. It makes that label suddenly seem much less random and potentially quite significant for individuals who react to it.
Precisely. It's information for a specific group who might be sensitive.
It really shines a light on how little we sometimes know about what's really in our food, even the common stuff. You know, there's initial curiosity I had. It wasn't just me being weird about a label.
No, not at all.
It was tapping into this whole hidden story of food processing. It definitely makes me want to pay a bit more attention to those ingredient lists.
It's empowering, isn't it? Understanding that even something seemingly simple like citric acid isn't always simple. It has layers.
Yeah.
And it really begs a broader question, I think. If an ingredient as ubiquitous and generally regarded as safe as citric acid has this kind of backstory and potential impacts for some, well, what else is in our food that might have unexpected origins or effects?
That's a really good point.
It just underscores the value of, digging a little deeper sometimes. Understanding the how and why behind ingredients can tell you a lot. It puts a bit more power back in your hands when you're navigating those grocery aisles.
Absolutely. What other common ingredients might be worth a second look? Food for thought, definitely.